Welcome to AI in 8 minutes or less, your daily AI update.
Okay, let me ask you something. What if building a robot was as simple as, say, building an app for your phone? That's the huge question that was kind of being answered all over the floor at NVIDIA's GTC conference. The world of physical AI is just moving so much faster than ever, so let's break down what's really going on.
All right, Section 1, a brain for a body. See, every robot, doesn't matter if it's a walking humanoid or a self-driving car, it needs one absolutely critical thing, a brain. And that brain, well, it's a powerful, super compact computer. And at the heart of so many of these new machines is NVIDIA's Jetson Thor. We're talking a 2,000 teraflop beast of a chip. It's designed specifically to be the central nervous system for all this physical AI. So, what's actually happening inside this brain? Well, according to NVIDIA's Spencer Huang, it's this constant, super rapid loop. A camera or a sensor, it sees the world. Then the chip reasons about what it's seeing and figures out what it needs to do. And finally, it acts, sending commands out to the robot's motors. See, reason, act. All of that happening in a flash, right there on the device itself. Okay, now what's really, really cool is where this is all headed. The next step isn't just about reacting to the world, it's about predicting it. With something they're calling world models, the AI literally imagines multiple possible futures just milliseconds ahead, and it's constantly checking those predictions against what's actually happening. I mean, this is the difference between a robot that's just running a program and a robot that truly understands its environment. It's a game changer. But, before we get to that awesome future, robotics has to get over this massive hurdle, one that engineers have been banging their heads against for years. This quote it perfectly captures the core problem. In simulation, you're always doomed to succeed. Think about that. You can train a robot in this perfect virtual world. But our world, it's anything but perfect. And that creates a trap, right? Because the more you optimize for that clean simulation, the further you might be getting from what's actually real. And this just illustrates the difference perfectly. On one side, in a simulation, physics are predictable. The environment is totally controlled. But in reality, oh man, the physics of just folding a t-shirt are incredibly complex. You've got infinite, unpredictable variables. So yeah, success in sim is easy, but success out here in the real world, that's hard won. So if every robot is different, and the real world is a total mess, how do you even begin to scale this? Well, what if you didn't have to rebuild the software from scratch for every single piece of hardware out there? And that brings us to this, OM1, from a company called OpenMind. What is it? It's an open source operating system for robots. And the analogy they use is perfect. They're aiming to be the Android for robots. Just think about that. A single, universal platform that sits right between the hardware and the AI's behavior. So the crucial thing here is that this totally breaks open the ecosystem. It can run on hardware from pretty much any company, and get this, just like your phone, it enables a robot app store. I mean, can you imagine downloading a new skill for your robot, whether it's, inspecting a pipe or helping you out around the house? This makes robotics accessible to people who are the real experts in their fields, not just coding wizards. And hey, this isn't just some far-off idea. There are already over 1,000 developers actively building on this platform right now. The momentum is real, and it's pulling the future of robotics from feeling, way out there to feeling like it's just around the corner.
Okay, we can talk about the tech all day long, but what really truly drives innovation, a lot of the time, it's not about the code, it's about the people.
This is a quote from Jan Liphard, the founder of OpenMind. My mom has Parkinson's, and I really wish there was something in the house that could find her and then make sure she's okay. I mean, this is his why. He's not just building cool tech for the sake of it. He's building a tool that could one day help his own mother. The robot doesn't need to do the laundry. It needs to find a person, see if they're okay, and call for help. Now that is a problem that matters. And that very human motivation was a theme we saw again and again. A member of NVIDIA's autonomous vehicle team shared a really similar thought. The goal isn't just some self-driving car. It's giving someone like his mom, who gets nervous behind the wheel, the freedom to say, take me to the store, and go where she wants, safely.
And what's so interesting is that the autonomous vehicle industry is exactly what's making this whole new wave of robotics possible. They really did pave the way.
So the AV industry perfected this process called the data flywheel. Here's how it works. When a car, or really any robot, fails in the real world, the system automatically analyzes what went wrong. That failure then becomes new training data to improve the AI model. And then an over-the-air update is deployed. It's this cycle of continuous improvement at a massive, massive scale. And a great example of this in action is the safety system in the Mercedes test car. There are basically two brains working together. You have an advanced AI model that does about 95% of the driving, but then you have this classic, rule-based safety system that's always watching from the passenger seat. It's ready to take over in an instant if the AI tries anything unsafe.
And just how good is that AI driver? Well, to get to its current smooth mid-30s safe driver level of skill, the model has gone through, wait for it, 2,300 iterations. 2,300. That is the data flywheel in action, turning every single mistake into a lesson learned.
Okay, so let's bring this all home. The key building blocks for the future of physical AI, they're not theoretical anymore. They're here. We have the powerful brain with chips like Jetson Thor. We have open software platforms like OM1, creating that common language. And we have the proven methods for training and deployment, pioneered by the auto industry. The tools are here, they're ready to go. Which really just leaves us with this one final thought. For the first time, the people who know the problems best, the doctors, the farmers, the factory workers, they now have access to the tools to build the solutions themselves. The hardware exists. The software is open. So the only question left is, what problem will you solve? If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.